So today's lesson, I know it's frozen. Today's lesson is on operations with functions. And there are 5 operations we're going to look at. And the first 4 are obvious. What? Adding, subtracting, multiplying, dividing. I totally don't want to call anybody out while I'm teaching. So if their computer's open or anything else, they're not listening to me, then I don't feel I want to do that. So there are 5 operations. They are adding, subtracting, multiplying, dividing, and a new one called composing that we're going to learn. And maybe a new symbol. When you compose 2 functions, the symbol that's going to be used is a little circle. And I don't know if you've seen that symbol before. Maybe you and Alex, you saw it. Did you see it before, Alex? Or was it brand new? Right? Yeah. So the first operations are going to be simple. So if you have 2 functions and you see this, all that means is take the 2 functions and add them. If I have 2 functions and they say, hey, subtract, that means you just take both functions and subtract them. Order matters with subtracting, not adding. If I see that dot means you multiply both of them. And if you see a fraction, that fraction means you divide. Subtracting and dividing order matters. Adding and multiplying, they don't. So, the domain, and what's the domain again? Those are all possible x values, right? All the numbers you could put into the function of the new function is the intersection of the combined functions. The domain is further restricted with the quotient function to exclude values in which the denominator is 0. So what we're going to do is we're going to add, subtract, multiply, divide, and then we're going to see if there's any domain restrictions that we need to worry about. So let's start. The 2 functions we have are x squared plus x and 3x subtract 1. I'm asked to add them together. So if I'm adding them together, f is x squared plus x, g is 3x subtract 1, and because they're polynomials, all I have to do is combine like terms. So we have 1x squared, x plus 3x is 4x, and the only constant is negative 1. So we added them together. It's a polynomial. When would there be a restriction for x? When you have a fraction in the denominator. When you have a square root sign, those are restrictions. Polynomials, there are no restrictions. So the domain is all real numbers. Subtracting. Well, when we subtract, order matters. So f will be first, then g second. Do you notice how careful I am using parentheses when I do order on operations? So when I look here, again, I have 1x squared, but this time I'm going to go x subtract 3x. So when you go 1 subtract 3, it's now negative 2. And when you subtract a negative, you have to be careful, that's positive 1. Again, are there any restrictions at all for the domain? No. So it's all real numbers. C, the dot means you're going to multiply. So we have x squared plus x and 3x subtract 1. If I'm going to multiply them, I'm going to have to distribute, FOIL. You might want to draw a box. I'm just going to multiply it out by foiling. So x squared times 3x is 3x cubed. X squared times negative 1 is negative x squared. X times 3x is 3x squared. And x times negative 1 is negative x. I look, are there any like terms here? So in the middle there are. So negative x squared plus 3x squared together is positive 2x squared. And then we have the minus x. Again, there's no restrictions for x. They're polynomials. There's not a fraction. There's not a square root sign. There's nothing that's going to cause something that's undefined. All numbers work for x. D. After I do D, you're going to help me with the rest. So, f divided by g. So what does that mean? That means that f is my numerator, that g is my denominator. Is the numerator factorable? It is. Factor out an x. I'm only doing that to see, will it simplify at all? Is there a common factor that could simplify? So that's all. Here, for the domain, do I have a restriction? And why do I have a restriction for this one compared to the other ones? Because now I have a fraction. What can the denominator not be? It can't be 0. So can you tell me the 0 of the denominator? And the 0 of the denominator is add 1 and divide by 3. So the 0 of the bottom is 1/3. All right. Do you get the idea? It's pretty simple, right? Adding, subtracting, multiplying, dividing. So now let's try it together here where you're going to help me. So let's start with Jessica. F plus G. What should I write down to add them together?
X squared plus 9, and then plus the square root of x.
Now, I gave you a super simple one. So if I said, hey, combine like terms, do you see any like terms? No, right? Nothing, right? Every term is different. There's nothing to combine together. But this is the challenge. Maybe not for you, but what's the domain here? Are there any restrictions for x? So what I'm looking for a restriction is, do you see fractions?
No.
Do you see any square roots?
Yeah.
Is there anything that you can't have under a square root sign?
The negative.
So how am I going to write that down? What's the domain restriction? Now, I'm not going to write down x can't be negative. So how do I do it mathematically to say x can't be negative? Any ideas? What's the smallest number x can be without being negative? What's the smallest number that x can be without being negative? Yes! So what's the bottom of my domain? Isn't that the smallest number x can be? 0? And then 0 to what would include all positive numbers? Another way to write this down is you could say x is greater than or equal to 0, and that would also be the exact same thing. Yes? Great job, Jessica. All right, B, we're going to subtract. Thomas, how do I subtract? What comes first? What comes second? Now, are there any like terms to combine? So we can leave it that way. Like I could write it over again without parentheses, but that's a waste. It is what it is. No like terms. What's the domain restriction? You were paying attention. That's awesome. So you see a square root? So it can't be negative? So it's from 0 to infinity, or x is greater than or equal to 0. Perfect. C. All right, let's see where we're at. Dan, are you ready? What does that dot mean? So what am I multiplying? All right. You ready? A little trickier than the other questions, but I know you have the talent to handle it. So what do I do? So what do I do? So you're going to go x squared times root x. Is that right? We're going to look at that in a second. And then 9 times root x. Is that right? So this is like yesterday's lesson. How do I combine them together? So x squared times root x can be written in a better way. You ready? I'm going to do that in the margin. Any ideas? So instead of root x, I'm going to write it as x to the 1/2. Are the bases the same? Are you multiplying? What do I do with the exponents then? If the bases are the same and you're multiplying, you would add the exponents. 2 plus 1/2. What's a different way to write 2.5 so that I can then go further? Because a mixed number, I'm going to be stuck. I need an improper fraction. Close. 2.5. Half of what number is 2.5? Well, I can think of it the other way. Half of 5, right? So 5 over 2? All right, we're not done. How do I write that as a radical? Okay, how do I simplify the square root of x to the 5? This is your 100% quiz, right? Yes. So the square root, see it's the world will now know, 100% quiz. So the square root of x to the 5th. Power of 2. How about, like, what's the even number that's super close to 5? Right? Is this what you really did? And you just skipped that step, right? The square root of x to the 4th is x squared, and what's left underneath? So this answer really is x squared. Did we just go backwards? Didn't we just go backwards? That's crazy, isn't it? So we went forwards, and then we went backwards. That's just silliness. I'm going to leave it at that. X to the 5 over 2 plus 9 root x. Do you see how we did like a full circle there? Man, that's good math and bad math all together. Good math, we can do it. Bad math, that it like spun her wheels, right? Good job, Diana. D. Let's do this. All right, Daniela. What am I doing for part D? What happened? Domain. Do you see that, Diana? They made you do the domain now. Now what? It's 0 to infinity, isn't it? So both of them actually are restricted, right? Like the square root of x, the square root of x. Perfect. That didn't throw you off. All right, Daniela. What does that fraction line mean? So what's the numerator? And the denominator? Root x. Now, there's, right, the denominator is g, right? Root x. There's nothing factorable, so we leave it. It's done. There's nothing that's going to simplify. But we do have a domain restriction. What do you think it is? Now, it is 0 to positive infinity, right? But this is different than part C. Do you know what makes it different? Is that it's in the denominator. Now, follow me on this. The question before, could x be 0 and be okay? Because the square root of 0, that's okay. But for this question, can x be 0? Because you can do the square root of 0, but now you have a fraction, right? So in other words, I'm going to go from 0 to infinity, but 0 is not included. So if I wrote this, it would just be an arrow to show that the denominator can't be 0. But the other questions, like the ones before it, I put a bracket because 0 was included. 0 was okay before. Can you see that? But now 0 is not okay, so I had to change it and be careful about it. Turn the page. All right, let's do some of this. Jocelyn, you ready? What am I doing with these two functions?
You're adding.
So g is x squared minus 4x. F is 2x cubed. What would happen if you added them? Are there any like terms here at all?
No.
So you could just let it go. There's no like terms to combine. You added them together. Do you know what the domain would be? Are there any square root signs or even roots? Are there any fractions?
No.
Is there anything that would give you an indicator that, there's a restriction? Are there no restrictions?
No, it's just
So it would be?
negative infinity to positive.
Perfect. B, I want to subtract. Chris Smith, tell me what I should do. So I'm glad you're careful about the order, right? When you subtract, so it's F first, then now, what I'm going to do here is I'm actually going to do one more step because that subtract sign belongs to both, and it's important for you to realize that's going to become a plus 4x. Do you see it? What's the domain restriction, Chris? Good. So we write down all real numbers. Beautiful. Part C. Sarah, what do I do?
You multiply 2x cubed and x squared minus 4.
All right. What do I get when I multiply them together?
You get 2x to the power of 5 minus 8x to the power of 4.
Perfect. Any domain restrictions?
No, your answer
Done. Right? All right, onward. Kim Cruz. How do I do this?
You're going to put 2x cubed over x squared minus 4x.
Do you think it's factorable to begin with?
Yeah.
So the denominator, how would you factor it? Because it's going to help you with the next thing anyways. So we're going to factor an x out, and then you're left with x subtract 4. Nothing is removable, but by doing that, I think it's easier to see the domain restrictions. Perfect. All right, on to another example. All of those examples, except for the square root, those are all polynomials. And the restrictions don't change for that polynomial. Here, these are no longer polynomials. These are now rationals. A rational is going to make it more fun, right? A little more interesting to do. So, Nicholas, are you ready for a little more fun? Let's do this. So what am I doing here in part A? I'm going to add them, correct? So I'm adding 1 over x plus 2 over x plus 2. All right. How do I add fractions? I like that. Thank you, Nick. Are the denominators the same? No. How do I make the denominators the same? What's missing for the first fraction that it needs? This is a great review. X plus 2. So x plus 2, top and bottom. What's the second one missing that it needs? It needs is it missing an x to match? Yes? Nick, is it missing an x?
Yeah.
Top and bottom. So now are the denominators the same? So the common denominator is x and x plus 2. Now look carefully. 1 times x plus 2, it's just x plus 2 and 2x. If I add them now, how many x's do I have?
3x.
And then the constant is 2. Done. Nothing removable. Can you tell me the domain restriction, Nick?
0 and -6.
Perfect. Well done. Now you saved someone trouble for part B. So let's see if Melissa can do part B and that Nick helped you do part B. So this time, what am I starting with?
2 over x plus 2.
Subtract.
Subtract 1 over x.
Now to subtract, like adding, you need common denominators. And the work to get common denominators, we're just already done. So we're just going to do it again. So what does the first one need to make it the same?
Next.
Top and bottom. And the second one?
The second one, x plus 6.
All right. Now, the only thing we need to be careful about here is that when I subtract, it belongs to both on top that follows, to both. So, I know the common denominator, like before, was x and x plus 2. If I combine the x's, 2x subtract 1x, 2x subtract 1x is x. Now this is the one, just think twice. What number should follow the x? Correct. So that subtract sign belongs to the 2 as well. And what's the domain restriction? What can x not be?
X can be 0.
And?
-2.
Perfect. All right, part C. Eduardo, what do I start with?
2 over x plus 2.
And then dot means multiply times. Now I know you know this answer. Do I need common denominators when I multiply these together? No. Is there any common factors that are removable? No. So what do I do?
Just multiply.
Now, to make life easier, I'm not going to distribute. I'm just going to write them beside each other. Is that okay? Because when I say, what's the domain restriction, what are you going to tell me?
0 and -2.
Done. D. He is smart. Kaylin. What am I asked to do in part D? Kaylin's also smart. Here we go. So what do I write down first? Now, I want you to notice I'm not going a fraction over a fraction over a fraction. Instead, because I know how smart you are, that you know when you're dividing fractions, you're not going to divide but times the, so what's the reciprocal? And then, do I need common denominators when multiplying? No. So what is it? What's the numerator? What's the denominator? Then, can you tell me the domain restriction? What's that? That's right. So the only restriction is x can't be 0. Perfect. All right, on to square roots. Alyssa, what do I do? Uh-huh. Then what? What's that? Is there anything I can do to write this? Do you know what you're tempted to do, right? Is to write down 2x and 4, right? That, when you have a square root sign over it, you can't combine underneath together. Do you know that when you multiply, you can take the insides together and multiply them? But adding and subtracting, you can't do anything. Either they're the same radical or they're not. They're not the same radical, so you let them go. So what do you think the domain restriction is? This is going to be a little more challenging. Say that again? I don't know if I heard it clearly. Square root of 2. So do you know that underneath the square root sign obviously can't be negative, right? So in order for it to not be negative, to know the 0 would tell me the smallest number it could be under the square root sign, right? What's the 0 under the square root sign? 2. What's the 0 under the other square root sign? So when you think of the domain restriction, right? Which one is smaller of those? Negative 6, right? Which one is bigger of those? Positive 2. There's an overlap, but they have to be true for both. So, for the one on the right, it has to be bigger than negative 6. That's negative 5, negative 4, negative 3, negative 2, negative 1. If you put those numbers in the first one, what happens? If you put in numbers bigger than negative 6, what happens underneath the first square root sign? Bad or good? Bad. So they have to be true for both at the same time. So I can't say negative 6 and bigger because it's not true for the first one. What's true for the first one is 2 and bigger. See, 2 and bigger is good for both. If the number is less than 2, it's bad for the one on the left. And it has to be good for both at the same time. So what's the domain restriction? 2 and bigger. And is that good for both of them? And that's it. It's a little more challenging when you're looking at 2 at the same time because the restriction has to be true for both of them at the same time. And if I look at one and then the other, I got to double check to make sure it's good for both. All right. B. Lisbeth. Yes? And we just talked about how they're not like radicals. You can't add or subtract them. Now the domain restriction. Same one, right? From 2 to infinity. So when you have a square root, the easiest way to find the domain restriction is to find the 0 under the square root sign. What did I just say to find the domain restriction for square root? Find the 0. So the 0 is negative 6. The 0 is positive 2. You have to go with the bigger number for them both to be happy. If you go with the smaller one, one's not going to be happy. Do you want me to repeat that again? For the domain restriction for square root, instead of graphing it and trying to figure it off the graph, find the 0 underneath the square root sign. If we have more than 1, you got to pick the bigger number of the 2 and use it. All right. C. Where are we at? Fancy Nancy. Let's do this. What are we doing? What does the dot mean? So what am I multiplying? All right. Are you tired? Okay. I'm going to help you. I want to tell you that when you're adding or subtracting, you need like radicals, but not for multiplying. Just the index has to be the same. Are they both square roots? Then I can multiply the insides together. And what do you get when you multiply the insides together? You get x minus 2 times x plus 6, right? Do you know how to FOIL that inside? X times x is? See, you know it. How about 6 take away 2? Oh, that's 4x? How about negative 2 times 6? See, if it's a simple FOIL, right, can you see how simple it is to multiply it out if it's simple? Now, this is a really challenging domain. So we're going to do it together. Is that okay? So, do we know that under the square root sign cannot be negative, right? The challenge here is that I have two numbers being multiplied. And you know what the challenge is going to be? That you can have a negative times a negative, and the answer is positive, and a positive times a positive. So there's actually going to be two parts to this domain. Are you ready to listen? Isn't it crazy? So the first part, remember we said that 2 or bigger? If it's 2 or bigger, both parentheses are positive, correct? So part of the domain is going to be 2 or bigger. But it's going to be a union. So there's going to be two parts to it. So if x is 2 or bigger, both parentheses are what? Positive, yes? Because a positive times a positive is positive. But the other thing that can be true is a negative times a negative is okay under a square root sign. So when are the numbers both negative inside the thing? So look at the two numbers again. What are the zeros again? 2 and what's the other one? So you know what the next one's going to be? From negative infinity all the way to negative 6. What happens here? From negative infinity to negative 6. And you might think, I thought negative 6 wasn't good. Well, if I plug negative 6 in and you're multiplying, negative 6 plus 6 is 0, and 0 times anything is 0, right? That's good. If I plug in any number smaller than negative 6, what happens to negative 7 and negative 7? Or negative 8 and negative 8? Can you see that both numbers will be negative? And a negative times a negative is positive. So this domain restriction is a lot more challenging. There are two parts to it. A negative times a negative and a positive times a positive. And how did I find those two numbers? They were the zeros, right? That we're looking at? All right, part D. Thank you, Nancy. Aaliyah, how do I do this?
You put on top for the square root of x plus 6.
And the denominator?
Square root of x minus 6.
Now, there's nothing I'm going to substitute. So I'm not going to let you think that you're going to be able to do that. You could write this with one big square root and do so on, but it's not going to help you any further. There's nothing to simplify. But how do I think through the domain restriction? Now, because of the square root on top, I got to look at both again at the same time. So what's the 0 on top? Negative 6. What's the 0 on the bottom? So the bigger of those two numbers is 2. And instead of putting a bracket, I have to put parentheses. Do you know why I put a parentheses around 2? Is it included or not included? Why is 2 bad for the domain? It'd make it 0, right? So before 2 is okay because it wasn't in the denominator. But because now it's in the denominator, I don't include 2. Man, those are good questions. All right. Example number 6. You ready? Pedro, what is it asking you to do?
To substitute F5 plus C5, to add it together,
To add them together and then do what?
to replace in soup.
And then substitute in and then solve it, right? So if I add them together, what answer do you get?
Negative 6.
If I add them together, what do I get?
4 minus x.
I get negative x squared. What else?
Negative squared.
Plus 2x, and then what? I'm adding these together. Negative x squared plus 2x plus what? 12. Yes? And then, when you plug in, what number would you plug in?
5.
And then you get negative 25 plus 10 plus 12. So altogether, that answer would be
Negative 3.
negative 3. Can I show you a second way you could do the same one? The second way to do the same question, in this case it was simple to do it this way, is that you could take 5 and plug it into G. You could take 5 and plug it into F and then add the two answers together. So in other words, if I took 5 and plugged it into F, what answer would you get? It's 4 take away 25. Negative 21, right? Yeah, and if you put 5 into the second one, what do you get? 18, and then altogether the answer is, there's no wrong way. I'm just saying, right? There's two ways you could do it. Plug in, add them together, or combine them and then plug in. Both are correct. So I'm going to choose to do the second way. Is that all right? Let's see if we can do this. Michael, if I choose to do it the second way, I'm going to plug negative 2 into F. I'm going to plug negative 2 into G, and then I'm going to multiply the two answers together. You got it? So if I plug negative 2 into F, what answer do I get? Is that something you can do in your head?
8.
Try again. 0. That's right. Negative 2 squared is 4, and 4 take away 4 is 0. Just order of operations. Try it again. I'm just kidding. The answer is 0. So why? Because 0 times, pick a number. Every number equals what? Get what I mean? Isn't that cool? Now, if I wanted to, I could do it. That answer is positive 4. But did it really matter that it was 4? No. Turn page. All right, here comes the new part of the lesson. So this is the part that you have not seen before. Another method to combine function is called composition. Given f at x and g at x, the composite function f, and this is how you read it, and that's going to be part of my goal today so that you know how to read it. We say f composed by g at x. F composed by g at x means f at g at x. It's a substitution problem. And if you want to write it down, it's called f composed by x, or by g, I mean, at x. So when you see that little circle, what word do we use? Because the other signs was adding, subtracting, multiplying, and dividing. What's that little circle? Composed by. And this is all it is a substitution question. Meaning that you substitute one inside of the other. Order matters. The second one gets plugged into the first one. Do you see how the second one is inside the first one? So the first one is outside, and the second one is inside. So here, the domain is going to be a little bit challenging. Remember this, Pedro? We did this on Alex, right? So the domain of the composite function is the domain of g such that g at x is in the domain of f. So we're going to see the domain of g, and then the domain of g is going to lead to the range of g, and the domain and the range are the same numbers, which is then going to lead to the range of f. All right, we're going to practice this together and understand this together. You ready? So, can I start first and then I'll call people? That little circle means what again? Composed by. And when you compose, it's a substitution question. The question is, what gets plugged into what? So G gets plugged into F. So what we're going to do is, we're going to write down f, but instead of writing down x plus 7, what did I take out and put in instead? Parentheses. Because it's a substitution question, wherever there's an x, what's going to get plugged in? Are you okay, Anthony? Are you okay? Do you want to pass, just to walk around a bit? And okay. Inside here is going to be x squared subtract 4. Do you see how I took one function and plugged it into the other? So I took out x, and what goes in its place? X squared subtract 4, right? Do you know when you solve a system of equations? You did that like 100 times last year. You did one of the ways is substitution, right? Where you take one equation and plug it into the other. That's what you're doing. Now, can you combine like terms here? Yep. Negative 4 plus 7 is 3. And then what's the domain? I want to look, what do we have here? They're polynomials. Are there any restrictions at all? So what's the answer? All real numbers. All right, let's try it again. But this time we're going to go the other direction. What's G composed by F? Well, now I'm going to write down G, but instead of X, what goes inside 4X, if I plug in the other direction, is X plus 7. Do you see how I took one function and plugged it into the other? In order mattered? Then, if I multiply it out, remember we were teaching about how to FOIL this? This is x squared plus 14x plus 49, take away 4. And that leaves me with x squared plus 14x, and then 49 take away 4 is 45. And again, they're polynomials. So what am I looking for domain restrictions? Square root signs and fractions, right? So no square root signs, no fractions, we're good. Just all real numbers. No restrictions. All right, let's try part A and see if you've been listening to me. Corey, you ready? So can you read that for me? How do I read that? It's not fog. Go for it.
F composed by G.
Exactly. F composed by G at X, right? And that's a substitution question. So how am I going to set this up?
We will be writing 3 minus beginning of parentheses, you can say x divided by x plus 1.
So do you see how you're taking G and you're plugging it into F? So you take out the X, use parentheses, and you get X over X plus 1. Is that right? All right, I'm going to challenge you. How do I write that as one fraction? How do I get common denominators and write it as one fraction?
They have a 1.
Sure, I can do that. Are the denominators the same? So what does it need that's missing? What does it need that is missing? Right, top and bottom. Can you combine like terms for me? And tell me what that is. What will the new numerator be? 3x, keep going. But isn't there an x over here? So it wouldn't be, it would be 3x take away x, which is 2x, right? And then 3 times 1 is 3. So it would be 2x plus 3 if you combine them together. Isn't that a great review from last unit? Is there a domain restriction here? Yes, we have a fraction. Look at the bottom. What's the 0 of the bottom? So x can't equal negative 1. Awesome. Good job, Corey. Let's try this again. Miss Marilyn. Can you help me? First, Marilyn, I want you to read it to me out loud so I know you know how to read it. I want to hear it. I can't hear it. So G composed by F at x. Excellent. All right, so what do I do to do that? What's that? That's one we're going to plug into, right? But what I want to do to make your life easier is wherever there's an x, I'm going to put in parentheses. So instead of x over x plus 1, do you see I took out every x and put in parentheses? What do you think goes inside the parentheses for substitution? So I put in f, right, which is 3 minus x. All right, can you combine like terms in the denominator? 3 subtract x plus 1. 3 and 1 are like terms. Can you combine them together? 4. So this is really 3 minus x over 4 minus x. That's it. There's nothing to simplify. Don't cross out the x's. But can you tell me the domain restriction here? X can't be 4. Perfect. Thank you, Marilyn. On to example number 3. Here we go. Clarissa, you knew it was coming. Read. Why do you say part A?
F composed of G at X.
Yeah, F composed by G at X, right? Perfect. Composed by, right? That's the big new word for today. That's a substitution question. So what should I write down to plug G into F?
9 minus 2 times 4x plus 1 is 3.
Now, I am not going to make you go 4x plus 1 times 4x plus 1 times 4x plus 1. Is that okay? Can you tell me the domain restriction? Clarissa, can you tell me the domain restriction?
You get a 1 over 4.
What? Do you see a fraction?
Oh!
Do you see a square root sign?
No.
So what is it?
Negative.
All of it, right? All right, thank you. Rosie, here we go. How do I do G composed by F? Say it out loud.
4.
No, say G composed by F. Say it.
G composed by F at X.
Perfect. All right, what do I write down?
It's 4 times 9 minus 2x to the power 3 plus 1.
So instead of 4x plus 1, I take out the x, put in parentheses, and then what goes inside?
9 minus 2x to the power 3.
All right, I am going to make you multiply this out because it's much simpler than the last one. So multiply it out for me. Rosie, multiply it out.
36 minus 8x cubed plus 1.
Any like terms?
Yes.
What?
So 36 and 1.
So what does that make?
37.
Any domain restrictions?
No.
Perfect. Turn the page. All right, Richard, let's go. How do you say it? F composed by G, right? At X. So it's a substitution. Can you take G and plug it into F? Go. What should I write down?
The square root of x squared plus 5.
Any like terms?
No.
All right. Domain restrictions. What is it?
0 and constant.
So X can't be 0. What's wrong with 0? I plug 0 in, score it a 5. That's okay. That's real. What's the other one?
Positive infinity.
Positive infinity? I can't plug positive infinity in. So what are you telling me? What are the domain restrictions? What can X not be? You know what the answer is? Even though there's a square root sign, why is it all real numbers? Why does every single number work in this case? It is impossible to get a negative number underneath the square root sign, correct? No matter what number you plug in square, if you add 5 to it, it will always, 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 always be positive. Tell me.
Also take out an x of that, so the x is outside of the radical.
You can't because it's x squared plus 5. If it was multiplying, you could do that, but not adding. But can you see that all numbers work? That just because it's a square root doesn't mean that there's a restriction. In this case, there's no restrictions because it's impossible to get a negative number in a square root sign. Yes? Thank you, Richard. Part B, let's do this. Evelyn, how do I do it?
You write x.
No, how do you read it, first of all?
G composed by f and x.
Okay, so it's a substitution question. F into G, right? So G is,
X squared. So x plus 5 squared.
so instead of x squared, I take out the x and put in the square root of x plus 5, right? Can you simplify that?
Yeah.
What would I write down?
X squared plus 25.
The square root and the square completely undo each other. They cross out. And what's left underneath is x plus 5. Any domain restrictions? No. Done. All right, example 5. Amelia,
So you
read it first. Fog x. Is that right?
f composed by g.
That's right. So how do I do that?
So you would plug in the g of x function into the equation into the x value in f of x.
Love it. So G gets plugged into F. So take out the X in F and then put in parentheses. And what goes inside the parentheses?
The cube root of x plus 4.
All right, simplify it.
So you put the cube root and the power of 3 cancel out.
That's right.
So you'd be left with x plus 4.
Mm-hmm. Keep going.
That is, you could put minus 1. You should see. So that'd be x plus 3.
Perfect. Any domain restrictions? Perfect. Part B. Claudia, how do we read Part B? F. Perfect. So what should I write down if it's G composed by F? So I'm going to write down G, which is the cube root of, and then instead of X, I'm going to put in parentheses. And then what goes inside the parentheses? X cubed minus 1. All right, under the cube root sign, can you combine like terms? So x cubed plus 3. Even though the cube root and the cube undo each other, the plus 3 prevents us from simplifying it. So that's as far as you can go. Are there any domain restrictions for cube root? Perfect. All real numbers. Done. We're almost there. Now, what's different about example number 6 is we are evaluating at a number. Do you see that? All right, Genesis. So can you read that for me? I'm going to help you through it. So to make this easier, we're first going to plug 3 into G. Whatever answer you get, you're going to plug into F, and that'll be your final answer. So what am I doing again? You take 3 and plug it into G, get an answer. Take the answer and plug it into F, and then you're done. So let's go, Genesis. If I plug 3 into G, what answer do you get?
Okay.
I'm asking you to take the 3, put it into G, and then go 3 plus 1 is? Thank you. Then you take the answer, and then what do I do with the answer? Take the answer and plug it into F. And negative 2 times 4 is? And the absolute value of negative 8 is? Can you see the journey I went on? So first I'm going to plug it into G, then the answer I plug into F, and then it's done. Okay, let's do this. Read that. So I'm first going to plug negative 5 into F. So do that. If you plug negative 5 into F, you can do that in your head. What answer do you get? 10. Then what do you do with the answer? Is you take the answer and plug it into G. And then what answer would you get there? 11. Done. All right, let's do that again. Can you see how simple that can be? Jimena, let's read this. Perfect. So what do I do first? Into where? Perfect. Let's just do that. I know you can do that. So if you plug 9 in, what answer do you get? Good. Now what do you do with that answer is you take that answer and plug it into F. Oh, and there's another one after it, isn't there? Plus 5 and root 5, right? So then take that answer, plug it into F. Is there a way to simplify that? What's the square root of 5 squared? Just 5, right? They undo each other. So you're left with 5 plus 5 root 5. Done. I can't do anything better with that. Dahlia, have I picked on you yet? Oh, they're all excited about it. So, they're being mean, but I'm being not mean. So, B, can you read that for me? So what do I do first? Let's do that. So look at F. This one we might need to write out, right? 7 squared plus 5 times 7. When you think you have the answer, let me know. It's 49 plus 35. What is that? Perfect. Then what do I do with the answer 84? So when I plug that into G, 84, I get the square root of 84 take away 4, which is there a better way to write it? Is there a perfect square that goes into 80 evenly? Hey, there's one. 16. 16 times what is 80? Yeah, someone whispered to you correctly. And the square root of 16 is? 4, and what's left over is 5. So it's 4 root 5 is the answer. All right, last part of the lesson is can we work backwards? So, can you find two functions that fit for this answer? So in other words, the answer you have is the composition. Can you break it down and tell me what two functions were used to get that final answer? So again, you're given the final answer, and you have to figure out what two functions were put together to get that final answer. It's not that bad. What is inside the parentheses? Excellent. That's G, right? Because that's the part that G is inside. What's on the outside of the parentheses? Cubed, right? So we just call that x cubed, meaning if I took out the x and put in that, it matches. Let's try it again. So we have f at x and g at x. Start with what's under the cube root sign? X squared plus 1. And then what's outside that is the cube root of x. So we look on the outside and inside. So if I took out x and put in x squared plus 1, would it work? Substitute in, right? All right, you ready, Cristobal? I haven't picked on you. You ready? In this example, what's in the denominator? That's my g at x, the denominator. Instead of that, take out the denominator and just put in x. And what are you left with? 4 over x minus 1. That's all we're doing. So for a fraction, you look at the denominator, that's your g, and then take it out, just put in x, and now you have f. That's it. Last one. Tell me something I didn't pick on that I forgot. Anyone? I picked on Tommy. Elizabeth, I have. So you guys have bad memory. I thought my memory's bad. Oh, Anthony! Here we go. But I was worried about Anthony, but now he's waking up. He's got this. He's now an all-star. Anthony? This is an absolute value bar. So you see it? So focus on what's inside the bars. That is my G. And then replace that with just an X. And what are you left with? Plus. Done! I knew it. GMAP, out! There's your lesson.